velocity omega. So it will have tangential velocity v, and this particle is going to move in a circular path. Fine. And there's a disk of mass, radius r, and mass m. First, what I did, I just took a small particle. What is the mass of that? dm. Then how v and r? V will be perpendicular to r. So what is the angular momentum of this small particle? dl is equal to dm into v into r. And what will be the angular velocity of all particles on this rotating disk? Will be omega. They will have different particles, will have different linear velocity, but all must have same angular velocity. So therefore, what is the tangential velocity? In fact, this v is equal to r omega. Substitute this dm into r omega into r, or this will be omega dm r square. What is the angular velocity of all the particles? Will be same. So therefore, I will sum up that. Now, why omega brought outside? Because all particles will have same angle, but different particles will have different mass and they'll be at a different distance from the axis of rotation. So what is this? This is the axis. Huh? This is the axis. So now, so what you get? Angular momentum. This should be equal to, what is dm r square? Moment of inertia. So what is the angular momentum of a rotating rigid body? It is I omega. Is telling how omega. I'll put like this. There's a direction of omega. What about L bar? L bar will be like this. Every problem, yes, it all depends upon the situation there. You can't say every problem like this. So what is the angular momentum of a rotating rigid body given by moment of inertia about that axis into angular velocity? Here, how L and omega, they are parallel. In this case, they are parallel. It all depends upon the type of rigid body and about which axis it is rotating. Most of the problems we do encounter where L will be along omega, but it need not be. It need not be that one. We know already rotational kinetic. What is rotational kinetic? Of I omega square. Now what we brought? We brought angular momentum of a rotating rigid body about axis. What it is? Moment of inertia into angular velocity. Let's take some examples. So let me take a pendulum, conical pendulum. Can you remember conical pendulum?